All right, well, here we go. Centripetal force requirement. Same stuff, very easy. Number one, the net force acting upon an object is blank as the direction of the object's acceleration. All right, so the net force acting on the object is going to be this is super simple. It's in the same direction that it's accelerating, because it wouldn't be the net force be right, but then it's accelerating left. That makes no sense, right? All right, a lot of these are repeats. Consider the top view of a clockwise motion. Draw an arrow indicating the direction of the... All right, so acceleration is always going to be inside. Velocity is just going to be tangent, so whatever direction it is, right, whatever. Easy. Label, da-da-da-da, I'm not going to worry about that. All right, let's look at number 3. Number 3 says, it pretty much says label the force. I mean, that's about what it boils down to. So remember, your forces are, for example, force of gravity, normal force, force of tension, force of friction. Am I missing any? Gravity, tension, friction, normal force, applied, I guess. That's another one. So we're pretty much looking at these and we're labeling the force. It's pretty straightforward. Pause it, do all of them, just take a guess, even if you're like, I'm not sure, just guess anyways, then unpause it, and then I'll go over it, right? So do that now. Ready, set, go. All right, so here we go. Planet orbiting the sun. Well, nothing's touching it, so that's got to be force of gravity. You can write gravity, you write Fg. A bucket filled with water held by a string swirling in a horizontal circle. That's tension. Tension. It's got a string, right? Passengers on a cliffhanger. It's pretty much a spinning ride, right? So it's spinning, so the force is going back at it. So when you're spinning on something, the force going back at you is going to be normal force. NORM if you want to do that. The moon orbiting, anytime I hear an orbiting planet, I think gravity. So force of gravity. Car making a turn on a level road. So it's turning, but on a flat road. So that tells me it's a force of friction. Car turning along a banked road. So it's turning on something. Banked means like slanted, right? So that would be like still force of friction, but also like I would say normal force. So friction, normal force. Let's do both. Force of friction / normal force, because the bank's putting normal force back on it. Halfback leans in and rounds a corner heading up a football field. That sounds like force of friction, and then you might also say applied force. Roller coasters at the top, so let's say force of gravity. Roller coaster at the bottom, that sounds like normal force. And closed in a spin cycle, the washing machine pushing back at it is going to be normal force. Alright, so that was a fast page, so let's do the next page. Ooh, do I want to do all these? I'll do one. Let's do the first one. So remember, this is very, very easy. It's just like the force of, it's just like Newton's problems, whatever. The last 3 you did, just do your formulas, piece of cake. So remember our formulas. Force of gravity equals mass times acceleration of gravity. And now we got to do the centripetal force formulas, right? So centripetal acceleration equals velocity squared over radius. And the centripetal force is just mass times centripetal acceleration, right? So these are your 3 formulas. Everything else is cake. So first things first on this one, write what we got. Mass equals 2. Radius equals 0.8. Velocity equals 3. All right, let's plug it in. So first off, let's do force of gravity. We have our mass, and we know this is 9.8. So we're going to do Fg equals 2 times 9.8. It's super easy. I mean, it looks hard, but it's easy. So our force of gravity, we know off the bat, is 19.6. That goes here, force of gravity, right? It's always this formula. Boom. Easy. Next, let's do centripetal acceleration. We know it's centripetal acceleration equals velocity squared. So 3 squared over 0.8. People mess this up. They either don't put 0.8 or they don't square it. So it's essentially 9 divided by 0.8. So our centripetal acceleration equals 11.25. And acceleration is always inward. And so we know it's at the top, right? That means it's down, because that's in, right? So now, net force. Centripetal force, net centripetal force equals centripetal acceleration, which is 11.25, times the mass, which is 2. So our net force equals 22.5, and it's the same direction, down. Now, last thing, tension force. So our total net force is 22.5 down. There's already 19.6 of it down. And they're both going the same direction, which means these two will add to get this. So you could do 22.5 minus this is going to give you the leftover, which is 2.9. So hopefully that makes sense. Hopefully. I mean, it's pretty simple. They're in the same direction, so they add. This plus this equals this. There you go. So, bottom line, remember your formulas. You're going to have enough to do at least one, probably two. And that's it. They're all pretty easy. They're pretty cake. If you guys want to check it, let me know. But that's it. You're good to go.